Hello, welcome back to Chapter 5, Section 6. We are dealing with the world-famous and sometimes infamous quadratic formula. I'm on page 361. If you're looking at the electronic version, that's page 52. And we're going to do problems 8 through 13. The big difference between this and the other problems we just did is that in this section, all of my square roots, I'm going to take the square root of negative numbers, so all my square roots are going to result in an imaginary component. But everything else is going to be the same, so don't panic about that. Let's get started. So first thing I do is I set my function equal to 0, and I identify the parameters. So my a equals 2, my b equals negative 2, and my c equals positive 3. Clean that up a little bit. The discriminant is b squared minus 4ac. So this is going to be negative 2 squared, subtract 4 times 2 times 3. Negative 2 to the second power is positive 4. 4 times 2 is 8, 8 times 3 is 24, so I'm going to subtract 24, which gives me my negative 20. Since the discriminant is negative, that means I'm going to have two distinct or separate, different from each other, non-real solutions. So they're going to be complex numbers with imaginary components. Excuse me. My quadratic formula is still the opposite of b plus or minus the square root of b squared minus 4ac divided by 2a. I'm going to use that to write the next step. The opposite of b is the opposite of negative 2. My discriminant I just figured out, that's negative 20, and 2 times a is 2 times 2. Opposite, simplify, multiply, and then we'll see if we can go further. The opposite of negative 2 is 2. Now, the square root of negative 20 is the square root of negative 1, which is I, times the square root of 4, which is 2, times the square root of 5. So I get 2i times the square root of 5. And 2 times 2 equals 4. Now if you remember 2 times 2 equals 4, I've got a 2, a 2, and a 2, so I can factor out a 2 from all of this. So my final simplified form, I'll write simplified here, is 1 plus or minus 1 times I times the square root of 5 divided by 2. So this is 2 times 1, this is 2 times I times square root of 5, and this is 2 times 2. Each of those 2's reduced, simplified out. So make sure you give it to me in simplified form. Number 9, set it equal to 0. Excuse me. Identify your parameters. Let's take care of that discriminant. So b is 6, so I get 6 squared. A is 1 and c is 12. 36 subtract 4 times 1 times 12 is 48. And 36 subtract 48 is negative 12. Now think about this. I'm going to take the square root of this in a moment. So this is the same as negative 1 times 4 times 3. So when I take the square root, I'm going to have each of those components. My quadratic formula is still negative b plus or minus the square root of b squared minus 4ac divided by 2a. b is 6, so I get the opposite of the opposite of 6. I was getting ahead of myself there. Negative 12 is my discriminant, and 2 times 1. So, opposite, simplify, multiply. Negative 6 plus or minus, I'm going to take the square root of all this. Square root of 4 is 2. Square root of negative 1 is I, and then I get the square root of 3. And 2 times 1 equals 2. Now I need to simplify. This is 2 times 3, this is 2 times I times square root of 3, and this is 2 times 1. So everything gets divided by 2. So I get negative 3 plus or minus I times the square root of 3. Number 10, set it equal to 0. Identify your parameters. Find the discriminant. So I get 4 squared minus 4 times 3 times 3. 16 subtract 36 equals negative 20. I always like, maybe you've noticed this because I've done, I've done about, 15 problems or so, and every time I write the complete quadratic formula in this step, I like to do that to make sure I don't forget anything. So I get the opposite of b, which is the opposite of 4, plus or minus the square root of that, which is negative 20, times, divided by 2 times 3. Opposite simplify multiply, so I get negative 4 plus or minus, negative 20 is going to be negative 1 times 4 times 5. And actually I did that one already, because for for problem number 8 I got negative 20 also. So this is 2i square root of 5 divided by 6. And notice this is 2 times 2, this is 2 times I times square root of 5, and this is 2 times 3. So those 2's are going to simplify. They're going to, I don't like to say the word cancel, but some people call it cancel. So I get negative 2 plus or minus I times the square root of 5 divided by 3. Make sure that you simplify. Number 11, and I know I'm going at this at a pretty decent pace. As always, pause it, rewind it if you need to. Set it equal to 0. Identify your parameters. Excuse me. Find that discriminant, b squared minus 4ac. So I get 4 squared minus 4 times 1 times 10. 16 subtract 40 equals negative 24. And I'll need to know this later. Negative 24 is negative 1 times 4 times 6. So there's my negative 1, which I'll take the square root of and get I. There's my biggest perfect square, which is 4, and the 6 is going to be left over. So that'll help me when I simplify later. Oh, sorry, got ahead of myself. That's what happens when I break my own pattern. Alright, so the opposite of b is the opposite of 4. The square root of the discriminant, square root of negative 24. And this is 2 times 1. Opposite, simplify, multiply. So I get negative 4 plus or minus, I got this. This is what I'm thinking of right now. This is 2i times the square root of 6 divided by 2. And now I need to simplify, because 4 divided by 2 and 2 divided by 2 simplify. I get x equals negative 2 plus or minus I times the square root of 6. Line everything up here. Excuse me. All right, last two problems. Set it equal to 0. Now, we did a problem before in one of the earlier videos where we had a negative in front of the x squared, and I went ahead and changed the sign for all of it. I'm not going to do that for this one. So I wanted to show you one way of doing it and show you a different way of doing it. And I mentioned in the previous video that it didn't matter if I did it or not. All right? So I'm going to leave everything as it is. I'm not going to change anything. That gives me my A is -5, my B is 7, and my C is -3. Make my C a little bit better. I'm getting kind of sloppy with my writing. So I get 7 squared subtract 4 times -5 times -3. Now, if you're wondering, okay, well, you're confusing me. Just for the discriminant part, and I'll point out the other stuff in a moment, but just for the discriminant part, if I had switched the signs, the -5 would have been a +5, and the -3 would have been a +3. -5 times +3 is +15, but so is +5 times +3. So it wouldn't have mattered. What about this? I would have used -7, and when I square it, I'm going to get 49 either way. So you get 49. Ooh, I got a negative times negative times negative, so that's going to be a negative. 4 times 5 is 20. 20 times 3 is 60. Or if I had done 4 times 15, I get the same thing. 49 minus 60 is -11. Okay. That's kind of nice, actually, because 11, the only factors for 11 are 1 and 11. And that means that I don't need to simplify it other than taking care of the -1. Quadratic formula is -b plus or minus the square root of b squared minus 4ac divided by 2a. So I get -7 plus or minus the square root of -11 divided by 2 times -5. Okay, now we talked about I'm going to get -11 whether I change the signs or not. But what am I going to get the same x values? Of course. Instead of -7, I'll have +7, but instead of -10 in the denominator, I'll have +10. And you say, well, what about this one? Well, the positive becomes the negative, and the negative becomes the positive. So the sign, it's not going to matter if I change the signs up here or not. Okay, if you don't believe me, switch the signs and do it yourself. I get x equals -7 plus or minus I times the square root of 11 divided by -10. Obviously, we want to simplify when we can, but guess what? We're not going to be able to simplify this. I am going to show you one thing, though. You can stop right here. This is fine. But I am going to show you one thing, though, and I'm only doing this because sometimes in the future, not with me, but in the future, you might get a multiple choice problem, and you're not going to see this. See all these negatives? If I go through and I multiply the top and the bottom by negative, I'm going to get +7, still going to get plus or minus I, just the plus becomes the minus and the minus becomes the plus, over +10. And this is what I would have gotten if I had switched all the signs at the beginning. But believe it or not, it's the same thing. All right? Just multiply, I'll write it down here. -7 plus or minus, and don't forget the plus or minus means you've got two of them, so you have to do them separately. I times the square root of 11 over -10. Multiply the top by -1 and the bottom by -1. That changes that to +7. That changes the positive to the negative. And the next time I do it, the negative to the positive, and that changes that to +10. So I'm okay with either one of these if you do it, but again, you might have to match it up with a solution if you have like a multiple choice type test, which may occur like on the ACT or the SAT or something like that. All right, finally, problem number 13. Set it equal to 0. Identify your parameters. Find the discriminant. 7 squared minus 4 times 10 times 4. Excuse me. 49 subtract 160. That's weird. And then that's going to be -111. Yeah. Negative b plus or minus the square root of b squared minus 4ac divided by 2a. b is 7, so I get negative 7 plus or minus the square root of negative 111 divided by 2 times 10. Alright, so I got the opposite. I got negative 7. What about negative 111? Well, I know it's odd, so 4, 16, 36 are not going to be factors, so I'm not going to end up with any of those as a perfect square factor. 25 is not going to be in there because I know the multiples of 25 are easy. 25, 50, 75, 100, 125, etc. Excuse me. I guess I could try 9. 111 divided by 9. I get a decimal, so I know that's not going to work. By the way, I'm going to show you why. I really didn't intend to talk about it in this video, but here's the thing. If you want to know if 9 is going to be a factor, add up the digits. 1 plus 1 plus 1 is 3. If you get a multiple of 9 when you add up the digits, then 9's a factor of the original one. And if you don't believe me, try it yourself. And if you want me to explain it a little bit more, I can, but in class, just not on the videos. So that's it. This is negative 1 times 111, so that's I times the square root of 111. 2 times 10 is 20. And nothing's going to simplify. So that's it. We're done. Alright, I'll see you in the next video.